Hi and welcome back. This is Unit 6, Day 1. So we are still practicing with negative exponents and with exponents of 0. And so our practice is going to involve substitution. Remember, substitution means that we are plugging in some sort of a value for a variable that's in our expression. So I have n to the negative 4 times w to the 0, and I want to solve that when n equals negative 2 and w equals 5. All right, so if I just take that at face value and plug in n equals negative 2, use parentheses. I have negative 2 to the negative 4 times w to the 0. W is 5. That's going to be 5 to the 0. All right. I need to relocate negative 2 to the negative 4. That's going to be 1 over negative 2 to the positive 4. Okay, negative 2 is in parentheses, so the whole negative 2 stays as the base, and my exponent becomes positive 4. Okay, times 5 to the 0. Well, 5 to the 0 is just 1, right? So it's going to be 1 over negative 2 to the 4th times 1. Okay, I can do this math because that means 1 over negative 2 times negative 2 times negative 2 times negative 2. Oof. Okay, or if you put that in your calculator, you need to put that in as 2, make it negative, and say y to the x button, and put in 4 as your exponent. And then you press equals, and the calculator will tell you what the answer is. This is 1 over negative 2 times negative 2 is positive 4, times negative 2 is negative 16, times negative 2 is positive 32. I sure hope I did that. 2 times 2 is 4. 4 times 2 is 8. Just kidding. It's let's try to do the real math. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. Just kidding. It is 1 over 16. That's our answer. No Jelly Ranchers for you guys this time. Okay, so you do have to watch your negatives. If you have a negative number that's being raised to a positive exponent, it's going to be a positive answer. All right, let's look over here at number 2. I have n to the negative 1. I know that my n is negative 2 to the negative 1 over w squared, so I know that that is 5 squared. Just so you know, you can actually rearrange this equation with the variables in it first if you want to. So I can either go straight to, this is 1 over n times w squared, and plug in my numbers here, or I know that I have negative 2 to the power of negative 1, so I'm going to move that to the denominator. It's going to be negative 2 to the power of positive 1 now, times 5 squared. That is exactly what you're going to have if you did the variables first. 1 over n equals negative 2 times w equals 5 squared. Notice those are the same exact thing. So if you're more comfortable manipulating the expression before you plug in numbers, that's totally fine. You do what works for you, please. Okay, that is 1 over negative 2 times 25, which is 1 over negative 50. Number 3, n to the 0 is 1. I'm not even plugging in my n value. And w to the 6th, well, this equals 1 over 5 to the 6th. And because I don't have a calculator here, I'm not going to actually figure that out. I'm going to leave it as 1 over 5 to the 6th and hope that my teacher is happy with that. Okay, or actually maybe I won't be lazy. If I had a calculator in front of me instead of my phone, I would do it differently, but we're going to put in 5. Oh, we're going to make it a scientific calculator. 5 y to the x, or this one is x to the y, so I'm telling it I want a, can you see that? I'm telling it I want to have a an exponent of, what is my exponent? 6. Okay, 15,625. See, I wasn't going to do that in my head. Ooh, it's 1 over 15,625. Okay, we prefer that to a big ugly decimal, incidentally. All right, 1 over n times w to the negative 1. If I arrange this with my variables first, I get w over n, which equals 5 over negative 2. We don't like a negative in the denominator either, so we're going to say that's negative of 5 halves. Or you can also say negative 5 over 2. Just don't leave that negative in the denominator, please. Okay, n to the third times w to the negative 1 is really n to the third over w, and we know our n from the top of the page is negative 2, so that is negative 2 in parentheses, because that's what I'm plugging in as n, over w. So that's going to be negative 8 over 5. And here, 2 times n to the negative 4 times b to the 0. Oof, that's just 1. Good thing, because we don't know what b is, right? They didn't give us any b values. Good thing we didn't have to figure that out. Okay, so that means 2 times n to the negative 4, which is the same as 2, over n to the positive 4. We do know that n equals negative 2, excuse me, so it's going to be 2 over negative 2 to the 4th, which we cleverly figured out up here. Negative 2 to the 4th is 1/16. Okay, sorry, I lied. Negative 2 to the 4th is 16. 1 over negative 2 to the 4th is 1/16. So we have 2 over 16, and that equals 1/8. Okay, negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is positive 16. All right, so yay, time for scientific notation. Scientific notation is super helpful when you're talking about really, really small things and really, really, really big things. So we might be talking about the weight of some very small bacterium or something. We might be talking about the distance in between particles of atoms, you know, so you have electrons and a nucleus and how far apart are they. Those are really, really small distances, right? You also might be talking about distances from one planet to another. Those are huge distances. So we use scientific notation to help us kind of simplify really small numbers and really big numbers. And we have some rules that we care about. Okay? Our rules when we are writing a number in scientific notation, we are going to have some number times 10 raised to a power of something. All right, so I got a lot of somethings going on in that, haven't I? So I might have something like 3.2 times 10 to the second power. This is in scientific notation. It is in scientific notation if this factor here is a. It has to be in between 1 and 10. It can equal 1. It cannot actually equal 10. See that? Okay, so 3.2 works. I could say 1 times 10 squared. That works because 1 is less than or equal to 1. It's allowed to be 1. I cannot say, so that one works, but I cannot say 10 times 10 squared. That's not scientific notation. I can't say 10 times 10 squared because my factor number in the middle here has to be in between 1 and 10, but it can't actually equal 10. So this is not scientific notation, but it is a number we can do, right? We know 10 times 10 squared, well 10 squared is 100. So we know that it has a numerical value that we can figure out. It's just that it was not written in scientific notation. Okay, so scientific notation just has specific rules where your a times 10 to the n, your a needs to be in between 1 and 10, and n has to be an integer, and that just means that you can't have 3.2 times 10 to the 2.3. That is also something that we can do mathematically, but that's not scientific notation, and we are not going to do anything with an exponent that has a decimal. Okay, so what we're going to do is go back and forth between scientific notation and standard notation. Okay, this number, 6.03803 times 10 to the 8th. Woof, that's a whole lot, right? So, hang on. If I wanted to figure that all out, it really does mean 6.03803 times 10 to the 8th. Well, 10 to the 8th is 10 times 10 times 10, 1, 2, 3, times 10, 4 times 10, 5, 6, 7, 8. 10 times 10 times 1, 2, 3, 4, 5, 6, 7, 8. So that is 100, 1,000, 10,000, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? So 10 to the 8th is this big number here. It is 100 million. If I want to, I can write this all out humongous like. Oops. Yep, nope, that's right. 0, 0, 0, 0, 0, 0. And multiply it all out. So what you're going to find when you do this is that when you multiply it all out, it effectively moves this decimal to the right, because it's a big number, so we're going to go to the right 8 times. My exponent is 8, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. That's my new decimal location. And you can't leave whoops there. You have to put in zeros as placeholders. So 6.03803 times 10 to the 8th is really 603,803,000. And so it would be 603,803,000. Okay, so of course, if I were to do this math, I would get 603,803 with all these zeros, right? 1, 2, 3, 4, 5, 6, 7, 8. And then when you multiply with a decimal, you have to take your end product and you have to move the decimal 1, 2, 3, 4, 5. So I'd have to move this decimal 1, 2, 3, 4, 5. And it would be 603,803,000. And that's the end of my number. And it is the big giant number that we came up with, 603,803,000. So you can see it's big and messy. If we write everything out, expand it all out, instead, we are going to say that if we are multiplying by 10 to a positive number, it means we're going to be making something much, much bigger, right? And so we're going to move our decimal to the right to show that we have a bigger number. To the right, the number of times you see indicated by that exponent. So I go 1, 2, 3, 4, 5, 6, 7, 8. I have to put in 3 zeros. 603,803,000, and I'm putting in commas so that it's easier to see that. Okay, 4.5 times 10 to the negative 3. Well, 10 to the negative 3, you know, is 1 over 10 to the 3. It's 1 over 1,000. So it's going to be a small number. I'm dividing it by 1,000. I'm making it even smaller. This negative number means that I'm going to make my initial number, it's going to look even smaller than 4.5. If you have a negative, you're going to move your decimal to the left. So I have my decimal here, and I'm going to go 1, 2, 3 to the left. That's my new decimal, and I fill in any empty holes with zeros. I personally like a leading 0 because it makes sure that I know where my decimal point is. This is your answer here. You are really saying 4.5 times 10 to the negative 3. So what we just learned is what you're really doing is 4.5 over 10 to the third, right? That's what that means. We're going to move that to the denominator. And that's really 4.5 over 1,000. And if you do that on your calculator, you will get 0.0045. All right. So 4.51 times 10 to the negative 5, it's going to be a small number because that negative means that it's going to be a really small number. I am going to write 451. This is my original decimal point, and I need to move it 5. It's going to be small, so I'm going to move it 5 to the left. 1, 2, 3, 4, 5. That's my new decimal point, and I fill in everything else with zeros. And if you want to rewrite that, 0.0000451. All right, if we're going the other direction, though, we have to figure out what is our factor. And remember, the factor is the thing that has all the rules. It has to be between 1 and 10. It can be 1, but it can't actually be 10. And so I'm going to say, and we also can call that factor a coefficient. I will oftentimes call it a factor, but I'm going to want some sort of a coefficient or factor that is in between 1 and 10. So it looks like my factor is going to be 2.8125, right? That's in between 1 and 10. So I had to move my decimal, whomp, whomp, whomp. I moved the decimal 3, but my number is very small. My number is very small, right? And so 0.0028125 is pretty small. So I need to show in scientific notation that it's small. So I'm going to have a negative exponent. 2.8125 times 10 to the, I moved it 3, but it's a small number, so I'm going to say 10 to the negative 3. 646 million, I'm going to say that my decimal point needs to be in between the 6 and the 4 there. It's going to be 6.46 times 10 to the something. Times 10 to the something. Well, I have a decimal that's indivisible here, and I went 1, 2, 3, 4, 5, 6, 7, 8. It is a really big number, and so my decimal, my exponent is going to be positive. This guy, it also is going to be 6.4. So notice it's 6.42. 6.42 times 10 to the, it's a small number, so I know it's going to be a negative exponent. And I had to move the exponent whomp, whomp. It had to move 2. Okay, 6.46, 6.42. Those coefficients or factors are really similar, right? However, if you look at the exponents, hugely different. These are really different numbers, right? This is a really big number. This is a really small number. All right, so you can always check Khan Academy. If you Google or use some search engine to find Khan Academy and scientific notation, you can find other practice problems if that scientific notation wasn't making sense to you. Okay, it really depends on your previous math classes, how much that's going to be review and how much that's going to be brand new. And also, if you need other stuff other than Khan Academy on scientific notation, check in with me or with your teacher, and we'll make sure that you have that. All right, so finally, we do have some problems to do from the classwork on scientific notation. So here they are. We're going from, make sure you've done these on your own first, right? Do these on your own first and then check your answers. 22,000 numerically looks like that. So scientific notation, if I want it to be scientific notation, I have to have a factor between 1 and 10. So I'm going to have 2.2 times 10 to the something. Well, that's a big number, and so it's going to be positive, right? Decimal is right there, and I would have moved it 1, 2, 3, 4. So I'm going to say that's 2.2 times 10 to the 4. You can always turn that right back around to check. Start with 2.2 times 10 to the 4. You're going to move this to the right. 1, 2, 3, 4. So you can always undo what you just did and make sure that your number matches what you expect it to be. Okay, this guy's a really small number, so I'm going to have a negative exponent. I want my decimal in between 3 and 3. So I had to move my decimal 1, 2, 3, 4, 5. My factor or coefficient is 3.347 times 10 to the, it's negative because it's really, really small, and we said 1, 2, 3, 4, 5. 59 million. You get to practice. That's 59,000, 59 million. Oof. Okay, so my factor is 5.9, 5.9, and it's really big, so it's going to be a positive exponent. And 1, 2, 3, 4, 5, 6, 7. Okay, be super careful because you want to make sure that you are actually writing in scientific notation, that your factor or coefficient in the beginning is in between 1 and 10. All right, this guy, my factor is going to be 2.8125. And I had moved that decimal 1, 2, 3. And it's a really small number, so we're going to say negative 3. Okay. So just be careful, be aware that if you have something like 59 million, it is 5.9 times 10 to the 7 in scientific notation. If I had, for some reason, tried to write this as 59 times 10 to the something, that would put my decimal point there, right? 1, 2, 3, 4, 5, 6. That's times 10 to the 6. So this is true. 59 times 10 to the 6 is the same as 59 million, but it's not in scientific notation. It's not in scientific notation because that factor is 59, which is not between 1 and 10. Okay, it is a legitimate number that we can figure out, but it's not in scientific notation. So just be careful with that. All right, great. Thanks so much for checking in.